What's good, team, and welcome to today's beginner guide to JavaScript. Now, this is a super exciting video. We have lots to cover, and I'm super excited to have it on the channel. It's going to teach you everything you should know about JavaScript from the ground up. You don't need any prior experience. We're going to cover all of the foundational concepts, all of the foundational theory that you should understand. We'll start off by first touching on what JavaScript actually is. Then we'll dive into the basics of JavaScript, which you'll need to know if you want to actually code in the language. That includes variables and data types, conditional statements, and loops and functions. If you get the hang of them, then you can do absolutely loads of stuff in JavaScript. And then at the end of the video, I'll make a recommendation for some resources you can jump into to really get your hands dirty and complete that learning process. As always, if you enjoy the video, smash the like and subscribe button so that I can continue to feed Doug a healthy diet. So the first thing we have to understand on our JavaScript journey is what actually is JavaScript. And an equivalent question that we could also ask is what actually is a programming language? Now, I like to think of programming languages as a combination of three things coming together. Number one on the list is the syntax. Now, the syntax of a language is the rules. Different languages that we speak have different rules that if you don't use them, you are nonsensical. You don't make any sense at all. So we have to follow the rules of JavaScript so that the machine can understand what we're doing, what we're saying, what we're telling it to do. In addition to the syntax, we also have the logic. Now, the logic is essentially the instructions. It's like writing a recipe book. We have the syntax, which is how you write the actual instructions, and then we need the instructions themselves to be able to create a recipe. And this is basically what we do with the computer. We give it a recipe of instructions written in a syntax to then go and execute. And often, this is where the third part comes in, they act on data. Together, syntax, logic, and data, which is the information, are the troublesome trio that together create programming languages. Programming languages use syntax and logic to manipulate data and basically do all sorts of amazing things. Now, the last thing to know about JavaScript is that we script it and then we run it. So we write the instructions and then we run the instructions, although it's actually the computer that runs the instructions and does all the operational good stuff. So now we understand a little bit about JavaScript. Let's take a look at the basics of the actual programming language. And to do that, we'll start off by asking the question, what are variables and data types? Now, if you haven't heard of them before, a data type is a type of data. Probably not that big of a stretch of the imagination. And it's important to know that JavaScript only understands certain types of data. Now, we humans, if someone gives me a number, I recognize it as a number, and coincidentally, JavaScript does as well. And that is a great example of a type of data. A number is a number. On the other hand, we have variables, where variables can be thought of as labels. So basically what we have is certain types of data, and then we have a labeling system for that data known as variables. To give an example, here we have number of eggs, and that is equal to 13. 13 is a valid data type, it's a number, and we assign 13 using the equals operator to the variable number of eggs. So when I refer to number of eggs, you can probably infer that I have 13 eggs. Now, just to extend that train of thought a little bit, what happens if I write number of eggs times 2? What do you think that evaluates to? The answer is 26. We understand that the number value 13 is assigned to the variable number of eggs. And so when we use the variable number of eggs and then multiply it by 2, we can essentially think of that being as equal to 13 times 2 gives 26. Now, just to carry on about variables a little bit, there's a few rules that you have to understand. First and foremost is that variables must be instantiated. This means that we can't just go willy-nilly throwing out variables without first telling JavaScript that we're going to be using a variable. Now, the way that we tell JavaScript we're going to be using a variable is by declaring it. We declare that this is going to be a variable number of eggs, and we're going to then assign the number of eggs to it, which is 13. So we have different declarations that we can use to instantiate our variables. Now, one thing to know about the declaration is that it only has to be done the first time we use the variable. there on afterwards, we can just use the variable willy-nilly because JavaScript knows that it was instantiated at an earlier point, and then we can go and keep using it afterwards. There's two keywords we can use to instantiate the variables, and these are the declarations. The first one is let, and that is when we have changing values. So when the value assigned to the variable is going to be changing. For example, if I eat 5 of the eggs, then I'm down to only 8. That value is changing, so the changing value means that we have to declare the variable using the let declaration. On the other hand, if the value is not going to be changed, for example, if no one eats eggs because everyone's vegan, then we can assign it as a const declaration. The other thing is that the name of the variable cannot contain any spaces. And so in this example, I'm using camel case, where every new word after the first one is just capitalized so that we can differentiate the words. And here we can see the use of the let declaration. We declare the variable using the let keyword. We define the variable name, we use the assignment operator, and we assign 13 to that variable. And just like that, we've ripped through variables in JavaScript. Now to dive further into the different types of data, there's a few of them and they're important to know. Earlier we covered that numbers are a valid data type in JavaScript. JavaScript likes numbers. For example, we could give it the value 100 million and JavaScript is absolutely cool with that. That is no worries. However, if we go and do some funky stuff that only us humans recognize, the machine is liable to get confused. So we can't use the commas, for example. That means that it would no longer be recognized as a valid number type. Now, the other cool thing about numbers in JavaScript is that they allow you to do operations. For example, on a calculator, you have two numbers, you can add them together, or we could multiply two numbers. So if we have the number 2 and we multiply it by 2, JavaScript can totally recognize that these are two numbers being multiplied using the multiplication operator, and it will evaluate them to an output of 4. Likewise, we can add 2 and 2 to also give 4. So we can see numbers are pretty straightforward. Next on the list is sentences or strings. So a string is basically when we have a sentence or series of words. We call that a string. You string the characters together. And that's basically just a sequence of alphanumeric characters. Now, if we want to tell JavaScript that this is a sentence, and then for JavaScript to be happy with that, we have to always use the quotation syntax. So basically, we wrap the series of characters, the string of characters, inside of quotations. An example would be hello world. Hello world is a sentence. We recognize that, but to make JavaScript recognize it, we would have to wrap it in the double quotation marks, the single quotation marks, or the backticks. All of these would be valid syntax for strings, and if we removed any of the quotations, then JavaScript would suddenly throw a tantrum and be extremely unhappy. Now, if we come back to the number of eggs example, I could actually take the value, the number 13, and wrap it inside of the quotations, and suddenly it's now of the string data type. Now, that's not something you would necessarily do because a number data type is probably more appropriate for that value. However, just to demonstrate the point of how we could turn a number into a string. Now, data type number 3 is called the Boolean. Absolutely brilliant word. Boolean. Talk about words that sound like they were made up on the spot. Now, a Boolean is a data type that represents the true or false value. You could think of the lie detector test. People are either telling the truth or they're not. And JavaScript understands that kind of stuff through the use of the Boolean data type. Now, for example, we could say if the number of eggs is equal to 0, that statement is either going to be true or false. And in JavaScript, we can represent that state or that condition with the Boolean value. Now, as I said before, true or false, those are the values and they're called Boolean values. And the other cool thing about Boolean values is that we have a special inversion character. It's the exclamation mark. So if I have the true value, true Boolean value, and throw an exclamation in front of it, that's equivalent to not true. Note that I made that a string just so it's extra clear, and not true is equivalent to false. So if we throw the exclamation in front of a Boolean value, it's going to invert that Boolean value. An example of how we'd use this with a variable is we could have the variable has eggs. So it's no longer number of eggs, it's just has eggs, which is either true or false. I either have eggs or I don't. And we could say let has eggs equal to true, and that is assigning a true Boolean value to the variable has eggs, and that could change at a later date, which is why I use the let declaration. Now, up next on the list is the array. Absolutely brilliant data type, and it is used for listing out items. For example, here I have the numbers 31415926. Can anyone guess what number sequence that comes from? Let me know in the comments down below if that looks familiar to you. Now, unfortunately, if we just comma separate some values inside of JavaScript, it will not be very happy, and that doesn't make a lot of sense to it. So instead, what we have to do is wrap them inside of the square parentheses, the square brackets. So the list that we had above now becomes the same list, except it's enclosed within the opening and closing square brackets. Every opening square bracket has to have a corresponding square bracket. Now, as for the values inside of the list, they can be of any valid data type. At the moment, we're using numbers. We could use strings. We could use Boolean values. We could even have lists or arrays within arrays. So it's a super useful data type. And as I said before, the items within are all their own valid data types, and each of them is located via an index. So if we wanted to get the value at the third index, which value do you think it might be? You might be inclined to think it's the 4 value, because this is the first, the second, and the third. But one thing to know about lists or indexing inside of JavaScript is that it actually starts at 0. So the first element is at the 0th index, the second element is at the first index, and the third element is at the second index. So if we wanted to get the value at the second index, we know that's going to be the third entry. And last but very much not least, we have the object. Now, I like to think of objects as dictionaries, the literal physical dictionary that you have in your house that tells you what all the words mean. And we can also think about it as a way of labeling items. For example, I can have a name and that equates to James. Or for example, in a dictionary, I have a word and there is a value or a definition associated with that word. And instead of having a 1, 2, 3 index like we do in an array, inside of a dictionary, we open it and we use the word as the index to find the definition. That's very equivalent to an object, to the point where they actually often call objects dictionaries. And in this case, if I wanted to look up something in an object, I look for the name and I find the value associated with the name is James. Now, to create an object inside of JavaScript, they are contained within the squiggly or curly brackets, the parentheses. And so the example above, we wrap what's known as the key and the value, name is the key, the value is the string James, within the curly parentheses, and we can have loads of them. Like in a dictionary, you have loads of different words and corresponding definitions, and they're just all comma separated. So we can also have an age, and that has the value 27, which is a number assigned to that key. Now, as I said, they're key value pairs, so the dictionary I just created above has 2 key value pairs. One is name and one is age. Now, once again, all the values on the right-hand side have to be valid data types. So you could have nested dictionaries, dictionaries within dictionaries, objects within objects. It's all the same thing. Absolutely brilliant data type and a great one to become accustomed with. And last, this one is not a data type, but it's so important to know. It's a code comment. How do we write code that JavaScript doesn't actually read? This could be a note to either yourself or someone else who might read your code, but you don't want it to be executed and you want to keep it a secret from JavaScript. Basically, what we do is we create code comments inside of JavaScript by starting every new line in the // Every line that starts with a / will be invisible to JavaScript. That's just a great thing to be aware of. So now that we've covered variables and data types, it's time to get into conditional statements and loops. Starting off with a conditional statement, we can kind of think of this as if true, then do this, else don't. And we can see the benefit of this inside of the logic where we write the instructions. If we have eggs, add the eggs. If we don't, use blood, because that also coagulates the same way that eggs do when you bake, which makes it a reasonable substitute, apparently. Now, the main conditional statement that gets used inside of JavaScript is the if statement or if clause. And basically, we give it a condition to evaluate to a Boolean value, which is either true or false. If it's true, then we proceed to run and execute the code contained within the conditional statement. And if it's not, then we just totally skip over it and it's no worries. Now, the way that we create an if statement or if clause inside of JavaScript is we start off using the if keyword and then we use the circular parentheses or brackets. and within them we have the condition. Now conditions always evaluate to a Boolean value, so if true, then we execute the code inside here, in which case we would, reach this code. If the condition was false, then we would totally skip over it. So they are super useful, and we can actually go a step further, and we can say if the condition is true, execute one body of code. Else, if it's not true, then we can run the otherwise code. For example, if we think of a user dashboard, we can check if the user is logged in. If they are, we can show them the home dashboard. If they're not, otherwise, we can show them the login screen to prompt them to log into their device, and then we can show them the dashboard. So conditional statements, especially the if clause, are super powerful in JavaScript. And with that done, we can jump into loops, which allow us to execute code numerous times while we only have to write it out once, which can be super, super handy. For example, you could have 3 lines of code and you could execute them 1,000,000 times inside of a loop, looping over them until you get to the end of the loop. In JavaScript, there's 2 types of loop. One of them is essentially, while this is true, do this. And the other one is, for a condition, do this. So those are the 2 kinds of loops that we can construct. The main one and most popular is definitely the for loop. So for a condition, do this until the condition is no longer met. Equally, for this many times, run this code. Now, the way that we construct a for loop is we use the for keyword, and inside of the circular parentheses, we have the conditions of the for loop. After that, we have the curly braces. We open them up onto separate lines, and any code contained within the curly braces, just like with the if statement that we learned before, will be run numerous times inside of this for loop. So for the conditions that we describe, execute this code multiple times. Now, to be a bit more specific about the conditions, there's 3 of them when we construct the for loop. The first one, if we're looping multiple times, we need a counter or an indexing system to keep track of how far through the looping conditions we have progressed. Typically, the variable that we use for that is I. Let I equal 0. We start I at 0, and we will count every time we do a loop on this I variable. The second part to the condition is the constraints, and we separate the parts of the conditions using the semicolon. So we have the counter, semicolon, and now we have the conditions of the loop. And this loop is only going to run whilst the value of I is less than 20. So it starts off at 0, it increments up to 20, and when it hits 20, we're going to then exit the loop, having run the code 20 times. And finally, the last part of the condition is how much to increment the counter every time we complete an iteration of the loop. In this case, what we've done is we've said, have the new value of I be equal to the old value incremented by the value of 1. So this is just going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way up until 19. As soon as it hits 20, the loop will not be run because this part of the condition is not met. I is no longer less than 20, it is instead equal to 20. So for loops are absolutely brilliant for automating tasks or running bodies of code numerous times and not having to write it out 100,000 times instead. Last on our list of things to cover is functions. The way I like to think about functions is basically code on demand. We predefine code for later use. When we use it later, this is called an invocation. So we define the code, we define the function, and then later we invoke the function to then go and use it and benefit from that code. And we can invoke it numerous times whilst only having to write it once. The basic anatomy of the function. First, we have the function declaration. Now, technically, a function is also a valid data type, but it can be a bit confusing to think of it like that. So we can just think of functions as functions, and we declare them using the function keyword. After that, we name the function. If we're going to call it later, we have to give it a name. And after we have the name, we have the circular parentheses. Now, the circular parentheses contain the inputs or the arguments. And this is basically any information or context we need to provide to the function in order for it to run the code successfully. In this case, we're telling it to expect an input number. And then what we're doing is anything inside of the squiggly braces, like with the if clause, like with the for loop, is the code that is specific to the function and will only get executed when the function is invoked. So in this case, we can see here, whatever the input number is, we're going to multiply it by 2, and then we're going to return it. Now, functions don't have to return anything, but we can literally think of the return It basically says exit the function here and return out, spit out whatever the value is on that same line of the return statement. So in this case, when we invoke the function, we're going to return the input number times by 2. It's going to be doubled, and that's going to be left in the place of the function invocation. So we're going to call it, and then all that's going to be left over is what was returned out of the function execution. Now, as I said before, not all functions need to return stuff, and sometimes we just want to exit a function early, which we can do by throwing in an empty return line and nothing is returned and we exit the function early. But sometimes also we want to return a value. For example, if I wanted to create a double variable, I could say let double, and that's equal to my function. I can pass in an argument or an input of 2. That 2 is received as the input number, it's multiplied by 2, and then it's spit back out of the function, and so all that will be left over here once the function is finished executing is the value 4. Now the last thing I want to touch on inside of JavaScript that is absolutely brilliant for everybody to know is the Console.log. And this is basically how we get JavaScript to speak to us. Now it's pretty straightforward. Essentially how it works is similar to a function, we have these circular parentheses, and inside of them, whatever we put in this case, it's the string that says hello world. JavaScript will then print that out. It'll say it to us back. It's basically telling it to be a parrot and spit out that information. Kind of like a print statement, we can just think of it as logging to the console. Console.log, the value inside of these circular parentheses. Now this is super helpful for debugging because we can use it to basically get some transparency into the brain of JavaScript. If your code is buggy, we can throw in a console.log to see what values are at this particular line in JavaScript, what values are assigned to different variables in JavaScript, and JavaScript is basically just going to tell us information. It's kind of like how we interrogate JavaScript to solve our problems. So that's a super good thing to remember. We can throw these lines in absolutely everywhere, and JavaScript will speak to us, print them all out, and we can take a look at what comes up inside of our console. Finally, where to learn JavaScript. If you want to really get into the nitty-gritty of JavaScript, get your hands dirty, I highly recommend checking out the tutorial that I have linked in the description down below, and there's even a full course on Udemy if you really want to become a pro at JavaScript. And as always, thank you so much for watching the video. If you've enjoyed, smash the like and subscribe buttons. I love that support. And if you really want to help the channel, join the channel, become a member. It means a lot. And yeah, as I said, I appreciate the support. Catch you guys later. Peace. Learning to code? If so, be sure to check out the Learn to Code roadmap or dive straight in with these videos. That's a good